Okay, lesson 1-2, we're going to be talking about inequalities for this one. This first video here, we're going to work on just simple inequalities and how you guys can solve those. And then after this first video, we are going to be talking about two different types of compound inequalities. Okay, so go ahead and get going. I think I can get this done in 2 videos. Not going to make any promises though. Okay, so starting out with, when we are graphing inequalities, when you guys are graphing inequalities, the example would be if you guys had x greater than 5. Okay, x greater than 5. Now, I believe when Mrs. Ernett had you do this, she wanted you to put, the number 5 down there, and then she wanted 2 other values there as well, one on each side. I'm not going to make you guys do that. Okay, so the only thing when you guys graph these, the only thing that you need to have is you just need to have that one number that it's talking about. Okay, so the only number we need for x greater than 5 is we just need to know that 5 is on that graph. So just put the 5 in the middle. Don't need any other 2 numbers. You can totally put the other 2 numbers there if it helps you remember which side you need to shade on, but all I need to see is 5. Okay, now, when you guys are graphing these, the next question after you put the 5 down, the next question was, is there an open or a closed circle? And I hope that you guys remember the options would be either open or closed. So around that 5, if I have x greater than 5, this sign right here tells us if we need an open or a closed circle. And if you're talking about greater than or less than, either one of them, okay, if you're talking about either one of those, we are not including that number. The number is not included, which means that I would want to put an open circle on that 5 because I don't want that 5 to be included. So the only thing that you guys need to get from this first slide here is if you have a less than or a greater than sign, if we have a less than or a greater than sign, we want to have an open circle. Okay? And we want to have an open circle because we are not including the number. We're not including that number. Versus, the other example would be if you had a less than or equal to or a greater than or equal to. That equal to sign means that we are including that number. So for those cases, we would want to use a closed circle. Okay? So if you have a less than or equal to or a greater than or equal to, we want to have a closed circle. And the reason we want to have that is because we are including the number. Since we are including the number, we want to make sure that we close that in and show that that number is a part of this. Okay? So hopefully that you guys remember that. I guess we'll just finish this graphing example up here as well. Okay? I've got x greater than 5. So the numbers that are greater than 5 are going to be on this side of the line there. I would honestly, for you guys, I would prefer, rather than you guys just really trying to darken the arrow on that side, what I would have you guys do is just start here at the point and just make squiggles. I think it's way easier to just make squiggles like that to show which way it goes. Okay, the lady that used to teach here before me, that's how she did it. And after I saw that, I was like, I kind of like that rather than just trying to really darken it in because I don't think that shows it as well. Just take some squiggles and that'll show me which way you want to shade. Okay, all right. So that's graphing our inequalities. Okay, so I've got x less than 5, x greater than or equal to -2. So we got 2 examples here. Okay, remember, I only need to see one number. So if I have x less than 5, I'm going to put the one number down there, which is a 5. And then I'm going to ask myself, is that an open or a closed circle? So less than, I'm not including that number, so that would be an open circle. And then I need to find the values that are less than 5. So this is why Mrs. Ernett had you guys write those other values, is you would look at 6 and you would look at 4 and you'd say, okay, which one's less? Well, 4 would be less than 5. So I'm going to shade to the left. So you guys can totally write those if you want, but it's not necessary to do that anymore. Okay, so I'm going to shade over here to the left, and I'm just going to use my squiggles to show that's which way I'm going. Okay, pause the video, see if you guys can do this next one here. Okay, so this one is x greater than or equal to -2, so I'm going to write -2 down there. This time, what kind of circle am I going to have? Well, I am including -2, so I'm going to have a closed circle. Okay, and it's greater than, so our numbers that are greater than -2 are over here. Okay, so I'm going to do my squiggle line over to the right. Okay, hopefully you guys feel fairly comfortable with that there. I know you guys have done that in the past with your graphing. Other options for what you guys can do, I've had kids ask this before. You could do like a closed circle and then some of them will like draw a line out of the top of it. That works too. Okay, I'm pretty lenient on it. I just kind of did the squiggle thing, and I like drawing squiggles, so that's why I would have you guys do that for the recommended. Okay, next slide. Now, solving these things. Okay, we went over the graphing, okay, but now you can also solve inequalities. So the inequality I have is negative 2t minus 4 less than or equal to negative 6. Okay, to solve an inequality, we use the same rules. Same rules as solving an equation. Okay, so this is the exact same thing as solving an equation, except there is one rule, and that is when you are multiplying or dividing by a negative number. Okay, you have to remember to flip the inequality sign. Okay, so we will solve these things just like normal, except if you ever multiply or divide by a negative number, you have to flip the sign. Okay? And that is if I have to multiply or divide both sides by a negative or positive, that's when I flip the sign. Okay? So let's look at this example down here. I've got negative 2t minus 4 less than or equal to negative 6. My first step on this, because I'm just going to solve it like a normal equation, would be to distribute the negative 2. Okay? This is not a case where you need to flip the sign. Okay? Because I'm not multiplying both sides by negative. I'm just distributing. I'm just simplifying one side of it. Okay, so distributing that negative 2, that gives me negative 2t plus 8 less than or equal to a negative 6. I'm just solving this like a normal equation. I subtract 8 to both sides. Again, no reason to flip the sign there. That's just subtraction. The only time you flip is if you multiply or divide by a negative. Okay, so that gives me a negative 2t less than or equal to a negative 14. Okay, and then now to get rid of that negative 2, I've got to divide by negative 2, divide by negative 2. Now, I have now divided by a negative number, so now I'm going to have to flip the sign. Those two cancel, gives me t. Negative 14, negative 2, two negatives cancel, that gives me a 7. And I need to flip this sign and make it a greater than. T is greater than or equal to 7. Okay, so this is an example where I divided by a negative number, and then I had to flip my inequality sign. Okay, we need to go ahead and graph these after we solve them. We're going to graph these after we solve them. So I have t greater than or equal to 7. The only number that I care about is the 7. Greater than or equal to, so I'm going to have a closed circle, and I'm going to shade it to the right. Okay. Next page, you've got a couple examples there. You guys go ahead and pause this video, try these on your own, solve and graph them. Solve and graph them. Okay? All right, so we're going to go ahead and go through. You guys can just follow along and check. I'm going to subtract 2 to both sides. 3x greater than 6. Divide both sides by 3. Divide both sides by 3. And that gives me x greater than 2. Okay? Divided by a positive 3, nothing has to change. Graph x is greater than 2. The only number I need to see on here is 2. I've got a greater than sign, so that is an open circle, and greater than would be shaded over here to the right. Okay, next one, 2, and then I've got 5 plus x less than or equal to 5 minus x. Okay, first step I would want to do would be to distribute these. That gives me a 10 plus 2x less than or equal to 5 minus x. Okay, now I've got x's on both sides, so probably the first thing I need to do would be to get my x's together. So I could subtract 2x, subtract 2x. Okay, when I do that, that gives me 10 less than or equal to 5 minus 3x. Okay, so now I could subtract by 5, subtract by 5. Gives me a 5 less than or equal to a negative 3x. Now I've got to get rid of that negative 3, divide by negative 3, divide by negative 3. And that gives me a negative 5/3, because 5 and 3 don't reduce. And then that's going to be a greater than or equal to x. Okay? Now, before I graph this one, okay, negative 5/3 greater than or equal to x. That's not typically how we say that. Normally the x is on the left side. I would encourage you guys, if you guys are working these problems out, I would encourage you guys to rewrite this and not make this your final answer. I would write this and I would flip these two around, which would give me an x and a negative 5/3. Now, when I flip those, I'm going to have to flip that inequality sign. Okay, so negative 5/3 greater than or equal to x is the same thing as x less than or equal to negative 5/3. And we're way more used to seeing it written like this bottom example versus that top. So go ahead and make sure when you guys are solving these, your x should always be on the left side. Okay, now when I graph this, I only need one number. That's a weird number, but just go ahead and write negative 5/3. Okay, that's the only number I need. I've got less than or equal to, so I'm including that one, close circle, and then I'm going to shade to the left, because that would be on my less than side. Okay? So hopefully you guys felt okay with those. You guys could totally, you guys could have totally at this step here added x, and then your x would have been on the right side instead of subtracting 2x. A lot of different ways you guys can get to that answer, but we still should have the same answer in the end. Okay? All right, now there are two special cases on these. Sometimes when you guys do an inequality, you will get something that is always true. Okay, and basically what I mean by that, where it's always true, is your variables all cancel. Okay, and that will happen sometimes. Sometimes your variables will all cancel, and you're going to be given a statement that is always true. If you get a statement that is always true, your answer for that is going to be all real numbers. Any number will work. It is also possible that all of your variables could cancel. Okay, and if all of your variables cancel, you might get a solution that is always false. And if it's always false, that means that we're going to have no solution for our answer. So a couple examples down below here. It says solve the following. 3x minus 3 less than 2 times x plus 4 plus x. First step would be to distribute. Okay, 3x minus 3 less than 2x plus 8 plus x. Okay, I would want to combine my like terms, so 2x and x would need to get together there. So I've got a 3x minus 3 less than a 3x plus 8. Some of you guys at this point might be able to see what's coming. Now I need to get my x's together, so I can subtract 3x, subtract 3x. Those cancel, and oh shoot, those cancel too. So I'm left with negative 3 less than 8. Okay? So the question becomes negative 3 less than 8. Is that true or is that false? Is negative 3 less than 8? That would be true. Negative 3 is less than 8. That is a true statement. Okay? Now my answer for a true statement, is not negative 3 less than 8, and it is not true. The answer is all real numbers. Okay? That fancy R I drew there, you guys will learn about that next year in college algebra, but that fancy R means real numbers. So you guys can write that as an abbreviation, all real numbers. Okay? Now, the other example would be, on the flip side, is if we got a false solution. So let's look at this one. I'm going to distribute in my 4. When I do that, I get 4m plus 3 less than or equal to 5 plus 4m minus 12. Okay? Combine my like terms, so that 5 and that negative 12 there could go together. I've got 4m plus 3 less than or equal to 4m minus 7. Okay, again, you guys might be able to see what's coming here. Subtract 4m, those cancel. I've got to do the same thing on this side. Oh shoot, those cancel too. I get 3 less than or equal to negative 7. Is 3 less than or equal to negative 7? No, it is not. So that would be an example of a false statement. We could say that this statement down here is false. Okay, so what's our answer for this? It's not false. It's not 3 less than or equal to negative 7. Our answer would be that this has no solution. Okay, so a couple examples there of what you guys can expect to see. Okay, along with that, graphing these. If I asked you guys to graph all real numbers, well, all real numbers is just everything on this line. So you would just do a squiggle for the whole line and have arrows on both sides of it. As far as graphing a no solution, okay, well, graphing a no solution is none of it. So there is no solution, so you can't even graph a no solution. Okay, so I know we went a little long on that video, but that's everything we have for our simple solving equations. The next video we're going to do is going to be on our compound ones.